Now let's say I want to tweak this query a little bit. Right now it is just selecting all values from the student database. Let's say if I only want the names. So instead of select star, select whatever you mentioned after select will be the fields that are selected, or it will be the columns that are selected. So let's say instead of having all 4 columns, I only want to look at select name from student. Now if I run this, it will just return me the name column as with the values user1, user2, user3. So let's say if you are given a large database and you want to retrieve only very specific columns, then you just have to specify the columns and it will return it. If I wanted to return more than one column, let's say ID and name. So if I do select ID comma name and run this, it will return me user1, user2, user3 and their IDs 1, 2, 3. All right. So that is one. Now let's say this was about specifying the columns that we wish to retrieve. Now let's say I want to add some filters to the data that we have. For instance, I only want to retrieve the data where the age is not null. So for instance, I do not want this one, right? So for that, after we are done with the select statement, what we have to write is where. So where is where the filter starts. So now this where filtering will happen on the rows. Remember, what we write after select is the filtering that happens for columns. What you write after where, the filtering happens on the rows. So where, what was the column? Age is not null, right? I forgot if it was is not or not. So let's quickly run that and check. Okay, it is not null. So the age is not null. All right. So now what we got is we inserted these 3 users and now we added a condition that we have to select ID and name, but only where the age is not null. So it only returned as the users 1 and 2 because the age for user number 3 is null. All right. So where syntax, to cap it up once again, where syntax is used to specify the condition that is supposed to be met for the rows. So it is the filter that is supposed to be applied to the rows. All right. Let me add a few more tables, a few more rows to the database so that we can play around with it further. Number 4, and we'll make the username as null. We'll give this the age of, let's say, 56. Give it CSE as well, right? Now let's say I want to retrieve the users where age is also not null and username is also not null. So, and what is the name? Name is not null. Now if I run this, it will still return me just 1 and 2 because for 3 the age is null and for 4 the username is null. If I remove this entirely, it will give me all the 4 rows. So if I run this now, it will give me 1 2 3 4. Since the name for the user 4 is nothing, it is just returning us blank. All right. So this was the where clause. Now let's say I want to select only distinct values or unique values, right? So for instance, here you can see that there are 2 students with the same branch. So this guy also has CSE and this guy also has CSE. So here what we'll do is select distinct is the name, branch, right? Course, sorry. Select distinct course from student, and let's remove this. So now you can see that it will only return us the unique values for a particular student or for the particular case. So for instance, we said that we only want the rows where this course name is distinct. So two of these at CSE, so it only returned us one. All right. That was the use of the distinct keyword, which will only return us unique values. All right. Let's see what else do we have. Yeah. Now let's say I want to order this by age. Okay, I want to order the students by age. So I'll do select star from student and order by age. Run it now. So this was already in the increasing orders. So it already gives us that the user number 124, user 227, user 3 is age 56. If I were to make this 34 and run this again, you'll see that first is user number 2 with age 27, then user 34, the user with age 34, user with age 56, and the null one remains at the last. Okay? All right. So that was order by. We can even include multiple logics inside the same SQL statement. Let's say for ordered by age, we want to select only distinct course. That is does not make sense because we have very limited data, but you get the point that say distinct, let's say username, not username, name. Right now we have created very limited data, so it won't allow us to do all of this. So, but the point is that you can have multiple different clauses inside the same SQL query, and it will allow you to execute all of this together. Okay. All right. The next thing is inside the where clause. Oftentimes we might not know the exact name. Okay. For instance, if we were to know the exact name, what we can do is where name equal to, let's say, user one. Let's try to run this, and it gave us the name of user one. All right. So what this had done is that it finds wherever the name is equal to user one and we returns it. But oftentimes what can happen is we might not know the exact name. We just know some idea कि इसके नाम में ऐसा कुछ कुछ तो था. So here what we do is where name equal to user. And now we specify that we do not know if there was something before or after it, but it should have the type of the word user. ठीक है? And now if we insert a new one, let's say 5, username is Matt, age 44, and department is PE, whatever that might be. Okay, due to whatever reason, this is not allowing us to show this. Let's see why that is. Sure if this would work. Okay, got it. So when we want to specify that the name is something like, we can't specify equal to, right? Because then it would not recognize that it is trying to find us a name that is similar to, but not exactly the same as this. So in that case, the syntax will be a name like percentage user percentage, right? Remember, so get why we were getting this issue, that when we specify equal to, it will try to do an exact match. However, here we do not want to do an exact match. We want to find something that is similar to this. Right, so name user percentage. Now if we run it, we're able to get it. So user 1, user 2, user 3, these are the three values that match, that have the word user inside them, and that's why this. Got it? So that was it. I'm very frequently referring to syntax here, so, and that is something that you are at liberty to do as well, because you don't really need to recall all the syntax. You only should be able to understand how all of these are used. However, some of the standard ones like select, insert, and so on, these are something that you should ideally know. Okay, cool. So far we are only working with a single table. Now let's say if we wanted to create another table. So let's say create table course. We'll do course name. This will be a varchar. And we'll do students, which will include the number of students, and this will be an integer. And we'll do a location. We'll do which will be a string, or a means a varchar. All right. So what we have done is we have created another table now. We'll insert some values into this quickly. So insert into course values. One of the courses is CSE. Number of students is, let's say, 56. And location is location A. This is one. Another is ECE. Says, let's say, 36. This will be location B. And similarly, location C for ME. So we'll have 12. Now, if I were to quickly view the course table, I see that this is the course table. Course name, CSE 56, EC 36, and ME 12. Now, what I want to do is I want to find out some data that is shared between these two tables. For instance, I want to get some rows or some columns, sorry, from this table, the course table, and some columns from the user table or the student table, right? So to be able to use two rows to two different tables together, what we need is a common column between them. All right. So this column, so how would you compare if some particular row in the user table maps to some particular row in the column table or in the course table? So that is possible using this common column. And the action that we perform is known as a join. All right. It is a join. Join is something that is very, very common and very, very frequently asked in interviews. We might not be able to go into depth all the while in this one, but I'll just give you a quick understanding of how a join actually works. All right. So now the common column between the user or the student table and the course table is the course name. Okay? Here it is known as course, and here it is known as course name. So what we'll do is select name from student. Now we specify inner join. What is the name of the other table? Course on student dot course equal to course dot course name. Let's try to run this one and see what happens. let's make it select star so that we are able to view the entire one. So here you can see we have a new table now, which includes ID, name, age, course name, students, and location. So how did we actually do this? What we did is we told SQL that there is one table student and one table course. Both of them will have a common field that is known as course. Both of them are mashed together by course. So now what you have to do is you have to combine these two columns, making sure that the same values are matching. So the course from the student table should match with the course name from the course table. All right. So the syntax for that is select star from student. This is actually what we went to print. And here is the interesting bit, inner join. So that means we are joining the two tables. Here we specify the name of the second table, which is course, and on. So after on is where we specify what should be the matching column. So student.course equal to course.course name. So table 1 dot column 1 equal to table 2 dot column 2. And we have to make sure that table 1 and table 2 are the matching fields. So what this would allow us to do is it would allow us to match two tables and allow us to determine what are the and to allow to us to view the data from both the tables together. So this is where I've specified inner join. Now, if you see that this has 4 values right now thus far, all right? Let's say in course values, I add another course, let's say AE, Automobile Engineering. This will also have 34 candidates in location D. Now, if I run this again, you see that there is no AE yet here, right? Why is that the case? This is because there is no value where a student has the course of AE, all right? So that's why in an inner join, this condition will never be satisfied because it has to make sure that student.course equal to course.course name. But for AE, this value will never be satisfied. So that's why it will be, this won't show up here. Now let's say if you want this to show up here, what we do is outer join. Now if I run it, let's just make it right join here. Now if you see, we also have the value of AE here. This should be full join, not outer join, is full join. Let's try full join as well. Yeah, this is better. Now as you can see that it has a list of 5 values including AE and DE. Okay, here is AE, here is DE. There are 6 values actually, my bad. And what full join does is that it will take all of the values from both of the tables, even in the case where one of the values is missing from either table. So for instance, there is a value for AE inside course, which is not present inside student, but that shows up here. There is a value of DE inside student, which is not present inside course, but that shows up here as well. So inner join will have the restriction that it will only select the values that are present in both of the tables. To make sure that even those values come which are present in neither of the tables or either of the which are present in either of the tables, what you have to use is full join. And there are two more things, that is left join and right join. What left join will allow you to do is it will only select the values that are present in the first column, that is the student column, but not in the course column. So you have to take this as a take home and try to do left join and right join here and try to find out what will be the values that will be printed out if we do a left join or a right join. Okay? All right, so that brings us to an end to today's webinar. To quickly recap everything that we have done so far, we first got an introduction to what is SQL. SQL stands for Structured Query Language, which is a means to actually add data, retrieve data, and update data from the database. The databases that employ this SQL language definition are known as SQL databases. Some of the most common examples are the PostgreSQL database, the MySQL database, and so on. Some databases that do not employ the SQL SQL language are no SQL databases, which stands for not only SQL, for example, MongoDB. All right. PostgreSQL is one of the commonly used SQL databases. It works on the concept of a database, table, records, and fields. So remember, records is rows, and columns are fields. To set up PostgreSQL, you will need two things. You'll need Postgres and pgadmin. You can definitely try this at home on your machines to see if you are able to set these up. To be able to add and work with data in the database, we use these different queries. So for instance, some of the common queries that are used are the select query, which is able to retrieve data from the database, create query, which is able to, with which we create a database or create a table in the database, insert query, with which we are able to insert data into the database, and then we can perform further customizations on the data using the where clause, the order by clause, and so on. So that brings us to the end of today's session.